Hello, welcome to lecture number 1 on differential equations. Today we're going to look at classifying differential equations. So for type, there's two different types you can have. There's ordinary, and this could be like dy over dx, dz over dy, or like d squared y dx squared. Those are all full derivatives. For partial differential equations, we use partial derivatives with the del operator. So like del y over del x, or del squared y, del x squared, etc. So this example, the derivative of y with respect to x equals 3xy is ordinary, and this one right here, the second partial derivative of y with respect to x plus the partial derivative of z with respect to y equals 2xy, that one is partial. You have partial derivatives in there, so it's a partial differential equation. Now for order, we look at the highest derivative. So in the case of something like this one, we have the first derivative of x with respect to y and the second derivative of x with respect to y. So we circle the highest one. We have the second derivative of x with respect to y. So it's a second order differential equation. In this case, it's ordinary as well. So something like this one, dy over dx equals 3xy. We see that there's only a first derivative in there, so that's a first order differential equation. And if you just had y, that would be a 0th order differential equation. Something like this is a little tricky and stumps some people. This is the first derivative of y with respect to x squared is equal to 2. This is not the second derivative of y with respect to x. So this one here is a first order differential equation. Alright, now let's move on to linearity. This part trips people up a little bit more than the first two parts. So when we're talking about something that's linear, like a line equation, y equals 2x, we get something of this nature where x isn't squared, there's nothing going crazy, and there's a coefficient in front of x that's a constant. In differential equations, it's pretty much the same as this, but we just have more variables and we have to look for different things. So let's take a look. We have dy over dx is equal to 2y plus 3x. This one here is linear, and the reason for that is y and its derivatives aren't squared or anything like that, aren't to the fourth. They're like how like a line would probably be. And like there's a constant in front of the y, which is 2, which is fine. And if there were like x in front of y, that'd be okay too, because it's a pure function of x, and that's part of linearity that we look at to see if it's linear or not. So let's try a few examples. If we had something like dy over dx equals sine of y, we have to take note of what the dependent variable is. So as you can see with the derivative, we're taking the derivative of y with respect to x. So y is the dependent variable. And it's buried in a sine function. So y is the dependent variable, and it's in a sine function. We can compare this to like a typical equation like y equals sine of x. And we know y equals sine of x is not a linear equation. It is sinusoidal. So we know from there that this one is not a linear differential equation because y, or one of its derivatives, it could be like y prime in there, is not linear. And it's a first order nonlinear differential equation. And it's ordinary because we're using full derivatives. Now I want you to give this a shot. Classify this equation for me. The equation is the first derivative of y squared equals x y prime plus y. I'll give you a second to pause and work that out for yourselves. So it's not linear. Why is that? We'll show you in a bit. Let's get to the easier parts first. So what's the order? We look for the highest derivative. It's a first order differential equation because we have y prime in there and dy dx. Those are both first derivatives, and that's the highest one. So it's a first order differential equation. And it's ordinary because we don't see any partial derivatives inside of it. So why is it not linear? It's because dy over dx, a derivative of y, is squared. This is a good cue that it's not linear. So look out for that when you're getting tested on this. All right, moving on. Let's do one more example, and this one will sort of solidify everything. So this is y triple prime equals y double prime y plus 2x y. So we want to find the order, the type, and is it linear? So we check for the highest derivative, and we see that it is 3. So it's a third order differential equation. Now let's take a look at the type next. And this is just a notation thing. Once we get past 2 or 3, sometimes you'll see them put them in brackets. So that last one is the nth derivative. Next is the type. This one's pretty easy because it is ordinary. They're all full derivatives. Now, for whether or not it's linear, it's not, and that's because the y double prime y, it has a coefficient that's not a pure function of x. So if we wrote it y double prime, it'd be y as the coefficient to y double prime, and that's not linear. So it'd be something like y equals x times x. How that's quadratic in terms of like a typical equation, it's just not linear. So let's review a little bit about what it means for something to be linear, because this is the stickiest point that I see with differential equation students. So remember these two things. First, y and its derivatives. Y, the dependent variable, that could be theta, time, x, z, whatever the case may be. The dependent variable and its derivatives must not be raised to a power. So that's a really important thing to consider. And then the second part is the coefficients in front of y, the dependent variable, and its derivatives must be pure functions of x only. So that could be like x squared, x cubed, sine x, etc. E to the x, things like that. So some examples of this could be like x, y prime. That is linear. And another example could be something like, I don't know, x prime squared, xy prime squared. And that's not linear because y prime is squared. And then sine of y, we already look at this one. This is not linear because sine is, or y is buried in the sine function. And last little example, 2y double prime. This one is linear. Technically 2 is a pure function of x. Thank you guys so much for watching this video. We'll see you next time.